This is section 15.3 on polar coordinates. So we'll be integrating using polar coordinates now. All right, so hopefully you've had polar coordinates in the past, but if not, we'll give you everything that you need. Okay, so 15.3, page 1010, the basic picture. So given a point in the xy plane, you have x comma y, but you could also have r comma theta. R is the distance away from the origin, and theta is the angle in standard position, just like in trig, in radians, where this is considered 0, this is pi over 2, 90 degrees, and so on. Okay. And you can see some basic relationships here. So for instance, r squared equals x squared plus y squared. And trig tells us that x is r cosine theta and y is r sine theta. You can put those on your cheat sheet if you wish. Tangent of theta is y over x, opposite over adjacent, or inverse tangent of y over x is equal to theta. So we'll need that a little bit later. Okay, this will lead to something called a polar rectangle. It's not a regular rectangle. So r is between a and b, theta is between alpha and beta. So you end up with a polar rectangle, which looks like so. Okay, where r, the distance away from the origin, you can almost think of it as a radius, goes from a to b. Theta is between one angle and another angle. So it's not a real rectangle, but as usual, if you chop the picture up into smaller and smaller pieces, right? So delta theta is small, delta r is small. It looks more and more like a quote unquote real rectangle, as you can see over here. All right, so my little change in area right here on page 1012. So little change in area. It looks more and more like a quote unquote real rectangle. Okay, tricky thing is that this is dr, little change in r. This, however, is a little change in arc length. Okay, and you might recall in trig, arc length s is equal to r theta, which means ds, little change in arc length, is r d theta. So the area of this polar rectangle is r d theta times dr. Normally we say r dr d theta is a little change in area dA. Okay, anyway, this is what you want on your cheat sheet, formula sheet, page 1012. To change the polar coordinates, if you have f of x, y, dA, okay, then you have this new integral. R goes from a to b, two different radii. Theta goes from alpha to beta. Okay, this just says anytime you see x, change it to r cosine theta. Anytime you see y, change it to r sine theta. And then you have to remember to multiply by an extra r. So dA is r dr d theta. Okay, a lot of times students will forget and just put dr d theta. You need an extra r. It's r dr d theta. Okay. All right, so what that will now mean, we have different varieties to find area. So first, area is a double integral of 1 dA. Okay, just like length is the integral of dx. So if you integrate 1 dx, you just have the length of the interval. That's one dimension. 2 dimensions, double integral of 1 dA is the area. In 3 dimensions, triple integral of 1 dV is the volume. Okay, so dA, we have dy dx or dx dy, and now we also have r dr d theta. Okay, so this is the setup that we want to use in polar coordinates. All right, so 15.3, page 1014. Here are some of the problems here. Some more here. Then page 1015. See, let me move my picture over a little bit here. That and that and that. Some more here. And I think that was about it. Okay. So, number one, this is the picture that they give us. So r is going from 2 to 5, and theta is going all the way around the circle. So the integral is f of r cosine theta, r sine theta, r dr d theta. So remember, dA is r dr d theta. R goes from 2 to 5, theta goes from 0 to 2 pi. Okay, so number 5, the picture is going like so and like so. Okay, so R is going from 1 to 2, theta is going from pi over 4 to 3 pi over 4. R dr d theta means the area. Okay, so here's the picture. So we're trying to find the area right over here. Okay, 9, double integral over the region R of sine of x squared plus y squared dA. Now, x squared plus y squared is a dead giveaway of R squared. Okay, R is going from 1 to 3, theta is going from 0 to pi over 2. So we have sine of R squared times dA, which is R dr d theta. All right, and the derivative of R squared is 2R, so I put an extra 2 inside and a half outside. And incidentally, this integral does not depend on theta, so I immediately take the theta out, which is indicated by that arrow, and multiply by the length of the interval, which is pi over 2. Okay, so again, theta is not involved anywhere here. These are all constants, so I could just take out the pi over 2. And sine of R squared, derivative of R squared is 2R when I do my U substitution, so I have a half out in front. So I'm going to have pi over 4. Integral of sine is negative cosine, so negative pi over 4 cosine of R squared. Quick double check, the derivative of negative cosine R squared is positive sine R squared times 2R. So that works. Okay, plug in 3, you have cosine of 9. Plug in 1, you have the cosine of 1. Okay, or you can distribute the negative and turn this around. So final answer, pi over 4 cosine 1 minus cosine of 9. 13. Double integral of arctan y over x dA. This looks scary, but it actually isn't. Okay. Remember, the tangent of theta is y over x, which means theta is arctan y over x. So in other words, this is just theta. Okay. And x squared plus y squared between 1 and 4. That means R is between 1 and 2. Y is between 0 and x. Y equals x goes up at a 45-degree angle. So theta is going from 0 to pi over 4. So arctan of y over x is simply theta, and then R dr d theta. All right, so integrate with respect to R squared over 2 times theta. R equals 1 to 2. Take out the half, plug in 2, you get 4, plug in 1, you get 3, so 3 halves. Integral from 0 to pi over 4 of theta d theta. So 3 over 2, theta squared over 2, from 0 to pi over 4. Plug in 0, you get 0. Plug in pi over 4, you have 3/4 of pi over 4 quantity squared. Final answer, 3 pi squared over 64. Okay, 15, we're asking for one loop of R equals cosine 3 theta. So a quick table, you plug in 0, you get 1. Plug in pi over 6, you get 0. And then I realized because cosine is an even function, cosine of negative pi over 6 times 3 is also 0. Sorry, I said cosine of pi over 6. 3 times pi over 6, which is pi over 2. Cosine of pi over 2 is 0. Okay, so one loop looks like so. Here's the pole. Pole is another way of saying the origin in polar coordinates. Okay, so one loop, I can argue by symmetry if I'm going from negative pi over 6 to pi over 6 by symmetry. Let me just go from 0 to pi over 6 and double it. So the area is 2 times the integral from 0 to pi over 6, R dr d theta, and you're going from 0 out to the function cosine 3 theta. All right, so R squared over 2, from 0 to cosine 3 theta, plug in 0, you get 0. Plug in cosine 3 theta, I have that 2 very conveniently cancels that half. So cosine squared 3 theta. Okay, and so you might recall from trig, cosine squared of an angle is 1 plus cosine of double the angle, double of 3 theta is 6 theta, divided by 2. Divided by 2 means multiplied by 1/2. So that's what happened to that over there. Never mind about this, I messed up. So integrate 1/2, integral of 1 d theta is theta. Integral of cosine 6 theta is sine 6 theta times 1/6 from 0 to pi over 6. Plug in 0, you get 0. Plug in pi over 6. If I plug in pi over 6 here, I'm taking the sine of pi, which is 0. So the only thing of substance is right here. So 1/2 times pi over 6. Final answer is pi over 12. Okay, 17, I wasn't going to do the whole thing, but I'll just give you the setup. You have 2 circles with radius 1. one centered at the origin, the other centered at 1, 0. I just need to find out where they touch. So I set, let's see, so x squared has to equal x squared minus 2x plus 1, okay, because if I do a little bit of algebra, that's 1 minus y squared is x squared, and 1 minus y squared is x minus 1 squared. So that means I have to set these two equal to each other. That gives me x is a half. If x is a half, I know cosine of pi over 3 is a half, and cosine of negative pi over 3 is a half. So my integration is going to be from negative pi over 3 to pi over 3 of this function. Okay, so that's my setup for that one. 19, under z equals x squared plus y squared, above x squared plus y squared less than or equal to 25. Well, that means r is going from 0 to 5. Theta is going all the way around 0 to 2 pi. Okay, z is what we're integrating, is x squared plus y squared, which is r squared, times dA, which is r dr d theta. So it's going to be r cubed. Okay, my integral doesn't involve theta, so take out the 2 pi. Integral of r cubed is r to the 4th over 4 from 0 to 2. So 2 pi divided by 4 is pi over 2. And plug in 5 to the 4th is 625. 625 pi over 2. Okay, 21 says above the unit circle bounded by 2x plus y plus z equals 4. A little bit of algebra. Z equals 4 minus 2x minus y. You're basically always integrating z to get the volume. All right, so 4 minus 2x, 2 r cosine theta, minus y, r sine theta. So this is my z, r dr d theta. That's my dA. R goes from 0 to 1, theta goes from 0 to 2 pi. Okay, distribute to r. So I'm integrating 4r minus 2r squared cosine theta minus r squared sine theta dr d theta. Okay, so integrate with respect to r, 2r squared minus 2r cubed over 3 cosine theta minus r cubed over 3 sine theta from 0 to 1. Okay, and let's see, what do I do over here? Yeah, if I plug in 1, I get 2 minus 2/3 cosine theta minus 1/3 sine theta. Okay, both of these integral from 0 to 2 pi, I know it's just going to come out to be 0. Okay, we integrate the cosine function, you get the sine function. Plug in 2 pi, you get 0. Plug in 0, you get 0, 0. Integral of sine is negative cosine. Plug in 2 pi, you get 1. Plug in 0, you get 1. It's going to cancel out. So both of these integrals are 0. So it's just 2 times the length of the interval, 2 pi. Final answer is 4 pi. So a quick reminder, area that we did in Calc 1 and 2, you're integrating f of x, which is the integral of y dx, area under a curve. So volume is a double integral over a region of z. Integrate z, or f of x, y, over a region r. Okay, 25, above z equals radical x squared plus y squared, which is square root of r squared, or r. Okay, and below x squared plus y squared plus z squared equals 1, the unit sphere. Okay, and let's see, I squared both sides. X squared plus y squared equals z squared. So z equals radical, this thing is radical 1 minus z squared, 1 minus x squared plus y squared, or radical 1 minus r squared. Okay, so it's below the sphere, but above the cone. So you have sort of an ice cream cone thing that we're trying to find the volume of. So everything in here. So first I have to find their intersection. Okay, so they touch in this circular region here. It's x squared plus y squared plus z squared, but right here z squared is also x squared plus y squared. Okay, so I have x squared plus y squared plus x squared plus y squared equals 1, or 2x squared plus 2y squared is 1, x squared plus y squared is a half. That's a circle center of the origin, and a radius is the square root of a half, or radical 2 over 2. Okay, so r is going from 0 out to radical 2 over 2. So r equals 0 to radical 2 over 2. Theta is going from 0 to 2 pi of the upper function minus the lower function. So upper is radical 1 minus r squared minus the lower, which is r. So upper is the sphere, lower is the cone, times r dr d theta. And this thing doesn't depend on theta, so take out the 2 pi. Okay, distribute. I have r radical 1 minus r squared minus r squared. And I decided to break this up into I1 and I2. So the original integral, I, is 2 pi times I1 and minus I2. So I take a little time out, figure out I1, figure out I2. So I1 looks like a regular U substitution. R radical 1 minus r squared. Okay, the derivative of negative r 1 minus r squared is negative 2r multiplied by negative 2 here, negative a half outside. So that's going to be 1 minus r squared to the 1/2. So the integral is 1 minus r squared to the 3/2 divided by 3/2 or times 2/3 from 0 to radical 2 over 2. That's negative 1/3. Okay, so if I plug in radical 2 over 2, if you square it, you get a half. So 1 minus a half is a half. So 1/2 to the 3/2 power minus plug in 0, and you get 1 to the 3/2, which is 1. So I have, what did I do? I made a positive 1/3 and turned that around. 1 minus 1/2 times square root of 1/2, radical 2 over 2. So clean it up, 1/3, 4 minus radical 2 over 4. I2 is much easier. That's just r cubed over 3. And let's see, plug in 0, you get 0. Plug in radical 2 over 2, you have 1/3 of radical 2 over 2 cubed. 2 cubed is 8. And radical 2 times radical 2 times radical 2 is 2 radical 2 over 8. And that cleans up to be radical 2 over 12. So finally, I is 2 pi times I1 minus I2. So 4 minus radical 2 over 12 minus radical 2 over 12, which is, let's see, 2 pi over 12, 4 minus 2 radical 2. And simplify, factor out a 2 and cancel pi over 3, 2 minus radical 2. Okay, 29. You have this thing, change the polar coordinates. So x squared plus y squared is r squared. So negative x squared minus y squared is negative r squared. Okay. This is a circle centered at the origin and radius of 2, but x is going from 0 to 2. So you're only in the first quadrant. You're just going like so. So theta goes from 0 to pi over 2. R goes from 0 to 2. Of e to the negative r squared, r dr d theta. The derivative of negative r squared is negative 2r. So multiplied by negative 2 inside, negative half outside. And let's see, this integral does not depend on theta. So take out the length of the interval for theta, which is pi over 2. There's a negative half. So e to the negative r squared from 0 to 2, which is negative pi over 4, e to the negative 4 minus 1, or multiply the negative through. So best final answer, pi over 4, 1 minus e to the negative 4. Okay, 31. You were given this, x equals radical 3 to radical 1 minus y squared. Y goes from 0 to a half. Okay, so I plug in radical 3. Sorry, radical 3y. That's the same as y equals 1 over radical 3x. Okay, so I go like so. Y is a half. Well, that means theta is pi over 6. And that makes this point radical 3 over 2 comma 1/2. Okay, so r is going from 0 to 1. Theta goes from 0 to pi over 6. Of x is r cosine theta. Y squared is r sine theta squared. R dr d theta. So I have r squared, r to the 4th. Sine squared cosine dr d theta. R to the 5th over 5. Copy the rest from 0 to 1. That's going to be 1/5. Okay, that's a very easy U substitution. Derivative of sine is cosine. That's basically sine cubed divided by 3, and you have a 1/5 from 0 to pi over 6. Sine of 0 is 0. So 1/15. Sine of pi over 6 is a half. 1/2 cubed is 1/8. So 1/15 times 1/8. Final answer is 1 over 120. Okay. Last one I want to show you is going back to 15.3, number 11. Okay, it says bounded by x equals radical 4 minus y squared and the y-axis. So that means x squared plus y squared equals 4. Okay, y-axis is here. So r is going from 0 to 2. Theta can go from negative pi over 2 to pi over 2. That's probably the easiest here. And I have e to the negative x squared minus y squared is e to the negative r squared, r dr d theta. Okay, and the integral does not depend on theta. So I take out the length of the interval from pi over 2 to negative pi over 2. That's pi. So pi comes out. The derivative of negative r squared is negative 2r. So when I do my u substitution, I need a negative 2 inside, negative a half outside. Okay, so that's going to be a negative pi over 2. And then e to the negative r squared. Again, to double check, what's the derivative of e to the negative r squared? E to the negative r squared times negative 2r. So that works from 0 to 2. So I have negative pi over 2, plug in 2, e to the negative 4, plug in 0, you get 1, or distribute the negative, turn that around. So best final answer is pi over 2, 1 minus e to the negative 4. All right, so that's section 15.3.